Hey guys, today I'm going to be showing you how to create an automatic web scraper using Python and DigitalOcean. Now, why would you even want to create a web scraper in the age of Kaggle and a bunch of other online public datasets? Well, the reality is that for a lot of data scientists, most of their time is actually spent doing data collection, data cleaning, data processing, everything like that. And so being able to create your own web scraper and process the output is a great piece to put in your portfolio that shows that you're able to not only think critically about what data you use, but also go out of your way to collect data that's not at your fingertips. So today we're going to be doing a small, simple project just to introduce you to the field where we want to collect the top headline on BBC News every 15 minutes. And I'm going to walk you through step by step how you develop the scraping script, set up the virtual server, which will do the scraping, and then eventually I'll create another video showing you how to do some basic data cleaning on it. So the first thing I'm going to do is just pull up the site we want to scrape. Here we've got bbc.com/news, and then we're going to right click on the headline we want. So this is what I'm going to consider to be the top headline. It's the biggest, it's at the top. It's, if you looked at the page, it's the part that stands out most. If we right click on it, we see this inspect element, which you've probably played around with a little bit before. And essentially, this bridges the gap between the visual web page that you see and the actual HTML code that is behind it. So HTML is the language for the basic structural markup of a web page, and it's a series of nested tags which describe different elements, such as images, headlines, and paragraphs. And the nice thing about inspect element is that it gives it a highlighted box that describes the area to which each tag applies. So right clicking on that, we can see that the headline is contained within this tag. If we drop down, we see that it's actually contained wholly within this H3 tag, which stands for a third level header. This is something like a subtitle, so it's not usually the main text on a page, but it is one of the main elements. And we can see here that the title itself is embedded within that H3 tag. So now we know the web page we're wanting to scrape, and we have an idea of what kind of tag we want to pull from it. The next thing we're going to do is open up a terminal and start using Python to find that. So I'm going to create a new directory called BBC just to keep everything in one place. And if I move into here, the first thing I'm going to do is create a virtual environment. Now, I'll be making a more detailed video on these in the future, but essentially for now, just think of it as a convenient way to group together packages you need for a specific project without having to install them to a system-wide installation of Python. So I'm going to run python 3-m venv, and I like to call my environments env, but you can call it whatever you want. Then I'm going to activate it with source env/bin/activate. And now any pip installs that I do are going to be limited to this env instance and aren't going to affect my other projects on my system. I'm going to install two things here, requests in BS4, and I'll explain what each of them do in a minute here. Okay, so now if I enter an interactive Python session, I can import what I want from those. So I want all of requests, and then from BS4, I'm going to import beautiful soup. This is going to make more sense in a minute. And then I just want to define the URL that I'm targeting. So because I make a lot of typos, I like to copy that directly. It reduces some errors. The next thing I'm going to do is I'm going to pull down the actual HTML code that you see here. So to do that, I'm going to use the requests module, and I'm going to save that information to a variable called page. By doing requests.get on my URL, Python is going to get online and pull down the HTML for that page. But the problem is that page is not human readable. It contains all the information we want, but the format is hard to work with. So that's where BS4 comes in. We can create a new beautiful soup object by calling beautiful soup on the content of our page and parsing it for HTML. Now, while it still looks like a bit of a mess, we can see that this is some of the actual code that's contained within the BBC webpage. The nice thing about this is that it's actually a hierarchical set of lists. So if we look down here, we see all these indentations for which tags are contained in which other tags. And the same is true for the structure of the soup object, which allows us to search for instances of different tags and pull out a subset of the web page. Now we know that we're looking for an h3 tag, so the simple thing to do is just to do a soup.find h3, and we'll see what that gives us. And we're lucky, it's actually the first h3 tag on the page is the headline that we want. And if we do the same thing but .text, it gives us exactly the headline with none of the other tags around it. Now, if it had been a bit more difficult, we might have to do something like soup.findAll h3, which would return a list of all the different h3 tags on the site, and then we could index those to some specific instance. But in this case, our work is easy. We know that it's just the first instance of an h3 tag, and then we pull out the text. So the next thing to do is just to exit out of here and start writing this to a file, an actual Python script which can do this automatically. So I use Atom for small text edits like this. You can use whatever you want. And I'm going to create a file called bbc.py. And essentially, we're just going to copy in code that we already used in our interactive session. Import requests from BS4, import beautiful soup, and now we are going to define our BBC URL, which should still be in my clipboard, yep. And now we need to actually pull down the page. So if you'll recall, we do page requests.get BBC URL, and then we want to create a soup out of it with beautiful soup page.content and html.parser, since this is an HTML document. And then finally, our headline is going to be soup.find h3.text. And then I'm also going to add a strip at the end here. I don't think it's necessary for BBC, but there have been some other sites that I use where they include white space on either end, and it's just stylistic. It doesn't add any textual meaning. So I think it's best to just strip it out at this step because it's not what I want to collect. Okay, so I'm just going to add a print statement for headline just to make sure that we're getting what we want. And now when we pop back over into terminal, we can test it. And just to confirm, the headline right now is UK badly underestimated Russian threat, and that's exactly what we returned with our script. So now we know that this code works for pulling down the headline that we want. But to make it a bit more functional and flexible, I'm actually going to wrap this all into a function and surround this with a try except. And then we're going to create a separate script which actually calls this collection method and writes it out to a CSV file. And this structure might seem a little redundant, a little roundabout right now, but it is going to make our code more robust in the event that something goes wrong either with our collector or with the BBC webpage itself. And it's also going to allow us flexibility to expand our collection to other web pages or other headlines in the future. So if we take the little bit of extra effort to do this now, it'll make our lives easier later down the road. So I'm just going to call this all grab BBC. And it doesn't need any parameters because all it needs is the URL, which is contained within this script anyways. I'm going to get rid of the print, and surround this all with a try and accept. And in the accept case, this means that something went wrong with pulling down the web page and finding the h3 tag. So in this case, we're going to set headline equal to something like collection error. And this will be a signal within our eventual dataset that we tried collecting, but we were unable to. The important thing to note is that this should be something which would never feasibly be an actual headline. Otherwise, that would lead to confusion within any analysis. And finally, we are going to return headline. Now, this is good for grabbing just the raw text, but I think another important thing to collect would be a timestamp. So this would be a string representing the time at which this was actually collected. And even though we are planning on collecting this timeline regularly, every 15 minutes, I think it would be more robust to add an actual timestamp in case we want to change the frequency of collection, or maybe something goes wrong and we miss a couple collections. So just to be safe, I'm going to import datetime. And then within here, I'm going to set now equals datetime.now, and the timestamp equals now.str/ftime, string from time. And here we can define the actual layout of the string. I prefer a very generalized least significant bit to most significant bit. So I'm going to start off with the year, and then the month, and then the day of the month, a space, and the hour, colon, minute, colon, second, dot, fraction of second. And then finally, we are going to add it to the return statement. So now when you call the BBC function, it is going to return a timestamp and a headline together. Okay, so the next thing we need is our script for actually calling this and recording it to a CSV. I'm going to call Atom on headline recorder.py. So this is going to be our main collection script, and we're going to be writing things to a CSV file, or a comma separated value. And this might not be the most proper or robust solution, especially if you're doing a large data collection. You'd really want something like a MySQL database or a MongoDB, but considering that this is going to be a very small data set and it's really kind of a toy example, I think that a CSV is a fine solution. Because frankly, it's very easy to work with in Python. So at the top here, I'm just going to do some import statements of things that we're going to need. And note that we need to import BBC because it's a separate file, but it's in the same directory, so it's easy for it to find it. Then we're going to define our output file. And this is going to be something like headlines.csv. Then we want to make sure that this file actually exists and that it has the correct column labels. So if not os.path.exists on our output file, this means that this block of code will execute if that file does not exist. Then we're going to do a with open output file in write mode as out file. We're going to create a new CSV writer using our CSV.writer on out file, and we're going to set quoting to CSV.quote minimal. So quoting is something that is done within CSV files to show that a something like a comma or a special character is contained within an entry and is not actually delineating columns in a row. So the quoting minimal means that it's only going to use quotes whenever it is necessary to inform anyone reading it that those escaped characters are contained within the same entry. I just think it makes it more human readable, but you could set it to whatever quoting policy that you want, as long as it will quote somewhat. And then we're just going to do a CSV writer dot write row. And here we're going to define our column labels. I'm going to use UTC timestamp, source, headline, and URL. Now this is a bit redundant right now. We're only collecting headlines from the BBC, so why do we need source and URL? And we don't right now. But if we wanted to expand this in the future, or maybe wanted to collect from a different part of the BBC site, it's going to make our lives a lot easier down the road if we're already collecting this information. It makes our data set more full to anyone else who reads it as well. So given that we're only going to be expanding this data set by maybe a couple hundred kilobytes a month, since we're only pulling one headline at a time, I think it's fine to be maybe doing something that's a bit wasteful with data in terms of storage, just because it's not going to affect the end product much. Finally, we're going to do an outfile.close. Okay, so now we are ready to actually write the headline, which means we need to reopen our output file in append mode. We don't want to delete what we already have. Still going to call it outfile, and we are just going to copy our writer from earlier. Now we are going to get a timestamp and a headline from bbc.grab bbc, and then we're going to do CSV writer.write row. And here we're going to match the columns above. We have the timestamp provided by grab bbc. Our source is BBC. Our headline is headline. And our URL is just bbc.bbc URL. Because if you recall, it is accessible within the script. So we're going to be able to call it from here. And after that's done, we can do outfile.close. Okay, so now we have a recording script which makes sure that our output file exists with columns, and then we append the current information to it. And it is relying on the code from the BBC grab function. Now you can see this is not very difficult or long stuff to write, especially if I wasn't concerned with making sure the file was there. Maybe I trimmed out some of the checks in the try except here. This could realistically be done in probably under 20 lines. The fact that we buffed it out to a mere 40 lines and added a bunch of checks and balances on our code to make it more robust is just good practice, but it's still not very long. So web scraping is not a very difficult thing in principle. There are going to be instances where it's difficult to locate what you want on a page, or you might have websites that try to block you, but those are things that with practice can be overcome. So web scraping is very doable. So now that we've got our code, we need to actually set up a virtual machine in the cloud, which will be able to grab it reliably every 15 minutes. So if you have not already seen my video on how to set up a droplet with DigitalOcean, you can go watch that right now. I've got a link in the top here, but if you want to use another cloud service like AWS or Google, go for it. I'm going to cut away real quick to set up my own droplet, and I would encourage you to do the same. So I'll be back in a second. Okay, I'm back. So I set up a small droplet, just the $5 a month tier, 1 gigabyte of RAM, 25 gigs of storage, just the most base tier you need, because you really don't need a lot of compute power to run a web scraper, especially if it's only doing collection and not a lot of processing. So in this window, you can see I'm SSH'd into emid at BBC Scraper, which is the host name of my test scraper here. And the first thing we need to do is we need to copy over our code to my home directory in here. I'm going to just make a BBC directory just to keep everything in one place. Also so that if I want to host other projects on this node, then I can just create separate folders and keep everything separate. So you can see right now there's nothing in this folder. But if I go to my local machine, I'm going to use the SCP command, which is a secure copy. And this allows you to transmit files to a remote server on a secure tunnel. So I'm going to SCP my bbc.py to emid at, that's the IP of my scraper. You can try logging in, but I'll have deleted it. And it's going to home emid BBC. If we run that, it should take about a second to authenticate and send it. And now when we run ls, we can see bbc.py. So we're going to just run this again with headline recorder. And now we have all the code we need. So if you'll recall, we needed a few additional packages for this. We needed requests and BS4. And once again, just to keep all our projects separate, we're going to want to create another virtual environment for this. So I'm going to do python 3 -m venv env. And it's going to take a second longer because this isn't a very fast computer. And if we do a source env bin activate. So now we can pip install requests BS4. And once these are installed, then we should have everything we need to actually run our code. So just to test, we do not have the headlines.csv on here right now. But if we run python headline recorder, we now have a headlines.csv. And when we enter it, we can see that it collects the timestamp, the source, the headline must have changed, and URL. So just to double check, because this is a different headline than we saw before, let's go back to the BBC homepage and refresh it. Okay, so you see that this is great. It's definitely working, because even though we didn't know the headline changed, we were still in the old one in this browser. You can see that it updated to Ukraine siege ends after President's bizarre video. And in the terminal, we see that that is exactly what is recorded there. So we're just going to exit out of there, and we are really almost in the clear. We've created the code, we've deployed it onto our droplet, which is going to allow us to run it effectively. The next thing we need to do is we need to set up what's called a cron job. And a cron job is sort of like a scheduled execution of a program, which will take place whether or not you're logged in, whether or not you have a terminal open. And this is going to allow us to have our remote server execute the code automatically without intervention. So to set that up, we're going to do a cron tab -e for edit. If we go down here for the bottom, you can see that I was already testing this out a little bit before. But I'll just comment this out and kind of walk you through it by scratch. So each cron tab command has 5 numbers or indicators at the beginning that tell it when to actually execute this. And everything after that is the command you're running. So the first number is the minute. So I want it to execute at minutes 0, 15, 30, and 45, because this corresponds to every 15 minutes. The next one is the hour. I want it to execute at all hours. Then we have day of the month. I want it all days. Month, all months. Day of the week, all days of the week. So if you wanted to do all of something, you're just going to throw a wildcard with an asterisk. And then it gets a little bit different than you might think for executing the actual Python script, because we don't want it to use the base Python execution. If we were to just type Python, first of all, this would use Python 2, and second of all, it would use the global Python install, which does not have our virtual environment packages installed. So instead, we're going to use home emid bbc env. So this is going to be within our virtual environment. And then the Python executable is at /bin/python. And then we want to point it to our file very specifically. We want to include the full path, because if we don't, then it's not going to be able to find it, because these commands are not executed from the directory of the BBC scripts. So just double check. We have our timing right. Every 15 minutes, it's using the env installation of Python with our packages accessible. And then it's executing on emid bbc headline recorder.py. And if we write this out, we can make sure that it's there with cron tab -L. Okay, so the final thing we need to do is to make sure our output is written correctly, because since it is not executed from the BBC directory, if we tell it to just write to headlines.py or headlines.csv, it's going to dump it in whatever location it's actually running from, which is not what we want. We want to be able to find the file easily. That means we need to go into nano headline recorder.py, and we're going to set our output file to specifically home emid bbc headlines.csv. Okay, so now we are in the clear. We have deployed the code, we've set up the cron job, and we've made sure that the output file is exactly what we want. So I'm going to cut away for a couple minutes and wait for the 45-minute mark to pass, and then we'll make sure that the data is collected. Okay, so it's now been 4:45 in my time zone, but because we've passed a 45-minute, that means that our code should have executed. So let us check if we have collected the headlines as we wanted. So if we do no headlines.csv, we now see that we've got a new entry just past the 45-minute mark, and as we expect, it is the current headline, which we can confirm with a quick refresh on the page. So I know that I didn't demonstrate it here because I was still logged in, but cron jobs will still execute even if you are not currently logged into the system. So even when I deactivate and exit, this will still continue running every 15 minutes for as long as I keep that job enabled and that server running. So that's about it for this video. That's how you create a simple web scraper to collect one headline every 15 minutes. Obviously, it would be a lot more useful if you expanded this to include possibly other news websites, or to maybe include other headlines on the same web page, maybe text of the articles. But those are all things that I think you're in a good position to start looking into and figuring out on your own now that you know the basics of how to work with these packages. So requests is what you're going to be able to use to actually pull down the web page, and then BS4 is going to allow you to search within that very easily. And anything past that is just formatting and writing your output. So make sure once again to keep it flexible and expandable so that you can update it in real time without having to restructure your data. And then make sure to use something like a droplet or another cloud instance just to make sure that it's reliable. And as a quick note, I used DigitalOcean here, but this was not a promotional video. I don't get any sponsorship for it. I've just been very satisfied with my service so far, and the pricing is competitive. So it's what I personally use. So in the future, I'll be making videos about how to clean up the output of it a little bit and do some basic analysis on an actual data set that I generated using web scraping. So I'll see you in the next video. Thanks. Oh yeah, and all of the code that I used in this is uploaded on GitHub, so I created a repository. It's going to be linked in the description, and you can find everything that I used and a little bit of example HTML just to look through. It also includes a link to a more formal write-up on how to execute all this on my personal webpage. So thanks again, and leave any questions down in the comments.